So here, the example says we have two forces acting on this rod or pipe, whatever it is, and we are asked to determine the, I would say, determine the resultant moment. These forces, let's say, create about, I have to tell you about which point, you can guess about 0.0, about flange, well, so mechanical engineers, so let's be more specific, flange at O, and this is 0.0. So, what do I do? Well, let's start with what I just told you, resultant moment as a vector about 0.0. I have two forces, F1 and F2, so let's say M1 plus M2, both of them are vectors. M1 would be R1 times F1 plus R2 times F2. All these are vectors. Let's start with the first one. R1. What is R1? Let's show it here. If you want to think about it, this is R1. I can also call it RA if it makes better sense, more sense. R1 is equal to RA. What is R1 or RA in vector space, in 3D space? If you want to represent that as a vector. Zero, 5, 0, exactly. So no I component, no K component, pretty much just J. So I'll just put it 5, J. And I already know F1. F1 I'm given is minus 60I plus 40J plus, it's okay. Thank you for telling me though, letting me know. So plus 20K. So I know R1, I know F1. All I gotta do is to find M1, right? Is just to do this cross product. R1 cross F1. We talked about this product, cross product. We said, well, I, J, K, we just need to find this determinant. R1, the second row would be Rx, Ry, Rz component of R1. Well, this is 0, this is 5, this is 0. And F1 is minus 60, this is 40, and this is 20. You can do the math from there. You'll get M1. I'll just expand this one, but you know, I'll try to leave these to you. If you can, I highly encourage you to learn how to use your calculators to do these calculations, but that's still fine if you want to do it manually. So if I go with the first one, first row and second, first row and first column, I get rid of, so that would be 5 times 20 minus 0, I. First row, second column would be 0 and 0. So I don't get anything from there. Plus. First row, third column would be 0 minus, so 5 times 60K. This will give you 100I plus 300K. This is M1. This is M1, vector M1. Let's look at the second force vector, or force F2, and what moment vector that one creates. So R2, and I'm talking about this. Let me see if I can use, there you go. I'm talking about this. Let's call this RB if it makes it better. This is point B, right? So that would be R2 would be equals to RB. What is the vector for R2, or vector representation of R2, or the position vector for point B? This is obviously a vector. This is also a vector. So what are the components of RB? Keep in mind, this is X, right? This is Y, and this is Z. 4, 5 minus 2. Thank you, Edward. Exactly. 4i plus 5j minus 2k. Hopefully everyone can see that. Now F2, well, I'm given F2 directly. I know it's 80i plus 40j minus 30k. And these are pounds, so should be more diligent with units. This is feet. So M1 becomes pound foot. This moment. So force times distance. Obviously R is not pound. R is foot. So from there I can calculate or find M2. That would be R2 times F2. I, J, K, unit vectors. R components, we have 4, 5 minus 2. And for F, we have 80, 40 minus 30. I'm not going to do the math for this one, but if you do the calculation for this one, you should get minus 70i plus 40j minus 240k. And this would be M2, and the unit for that also pound foot. So I have all I needed. Right? I wanted to find MR as a vector, obviously. Resultant moment about 0.0. So that give me MR. If you do this calculation, you just have to sum these two, M1 and M2, right? This one gives you 30. The second component, well, that's 0 from M1. Here is 40, so total we'll get 40J. And K component, we have 300 minus 240 gives you plus 60K. This would be the resultant moment, right?